Welcome to the demo of Customer Data Export capabilities in Student Financial Aid within Oracle Student Cloud. This feature enables you to efficiently export only newly created or updated data thanks to optimized export views in SFA that ensure robust change tracking with dedicated timestamp columns. It also supports secure, customer-controlled exports via API methods and organizes your data with clear folder structures and naming conventions, making it straightforward to adopt and scale within Oracle Analytics Server. This approach streamlines integration processes and minimizes redundant data handling. From a business need perspective, this solution enables organizations to efficiently extract only the necessary incremental data by taking advantage of familiar SFA OAS capabilities, supporting both operational efficiency and system performance. It also eliminates reliance on outdated, duplicative reporting views, streamlining data export processes, and reducing confusion. These enhancements help you better manage data integration and reporting tasks with less manual intervention and complexity. With this feature, you benefit from streamlined, high-performance data exports that minimize system impact and provide a foundation for scalable reporting and analytics. Additionally, detailed change logs and comprehensive documentation enable better oversight and compliance reporting. This combination empowers you to efficiently manage your data while meeting regulatory and operational requirements. We'll start by exploring the export document reports, then dive into the underlying views and data models, review the new export reports, and finally cover how to trigger these reports programmatically using the OAS API. This feature streamlines data extraction, enabling efficient incremental updates and full synchronization for your target systems. In the Shared Folder section in OAS, you'll now see an SFP export folder. Expanding this folder, you can see we have new export data models, export reports, and importantly, a new export view documentation report. By clicking open on the SFP export view documentation report, you'll see 3 tabs. All 3 tabs will auto-run when you click on the tab, but you'll notice you have the ability to run for view name, a specific column name, relationship, which is parent or child, and a release version for the changelog tab. So let's explore the export view documentation tab first. This tab was designed to look identical to our reporting view documentation report. Here you can not only see which views were created, but you can see which columns are in each view, information about the data you are pulling up, such as the data type, data length, precision, scale, if it is nullable, and if it is an identity column. You'll also notice a column comment description providing a short summary of what that column represents. Probably the most important thing to note about these new views is the addition of the ETL create datetime and ETL update datetime. These are crucial new fields that allow you to pull incremental updates for all of our export views. This means you will only pull data that was inserted or updated since your prior run. Moving to the Relation tab, you'll be able to determine if a view is a parent or a child of another view. All of the parent views are listed first and denote which column has a corresponding child view. You'll also be able to run the report for only specific parent views or child views. Understanding the parent-child relationship between our new export views is critical to being able to reliably construct the data on your target database. By knowing which views depend on others, you can load and validate data in the correct sequence, preserving integrity and accuracy during migration or deployment. Moving on to the changelog tab, you'll be able to determine what, if anything, has changed in a particular view. My report is currently blank because no changes have been made, but this will tell you the view and change completed and which release that update was made in. Now that we have an idea of what these export views are, let's move back to our catalog and review the data models. We have created a data model for every export view, and in some cases we have created 2. If you notice a data model that has delete at the end of it, that data model will pull in data that has not been updated or inserted, but instead deleted. This will be critical to ensuring your backend system is in sync with not only updates and created data, but data that has been deleted. You will not have to make updates to these views as we've already created a corresponding report for each view that we'll look at now. Moving to the export reports, you can see we have named the report the same as we named the data models. With that being said, you'll also see report names with delete at the end, denoting that this report includes deletes only. Opening the first report, you can see it auto runs with just the header information, meaning you'll see which columns will be present. The key for these reports is in the start date and interval and minutes parameters. These will be key to keep track of when sending in your API to run the reports. The start date time determines at which point you will begin pulling data. The interval determines how much data will be pulled. So if you enter a start date of December 8th, 2025 at 1 a.m. and an interval of 60 minutes, you'll return all the data that has a create date time or an update date time between 1 a.m. and 2 a.m. on the 8th of December. You'll need to monitor the amount of data in the view to determine the correct interval time to utilize for the report, meaning a report containing packaging data may need to be pulled with a smaller interval than a report that returns student addresses, for example. In order to pull historical data, you'll need to submit an SR to have this data backfilled. We'll create backfilled data starting with a date of January 1st, 1900 at 12 a.m. and we'll increment each column in the view with 10 millisecond adjustments. In order to pull this data, you should pull in small intervals. If you have the interval set to 1 minute, for example, that would return 6,000 rows, while updating it to 30 will return 180,000 rows. So when pulling historical data, be mindful of how much data you are pulling. Now I'll show you how you can pull data using the OAS API. Again, it is important to keep track of the start dates you've used and the intervals, so the next time you run the report using the API, you are only pulling data for an interval after your last run. I'll actually run the report using the API and the UI to demonstrate the same data is returned. I'll pull data from the address export report as shown here in the curl command. We have the parameter interval set as 500,000. Now this is obviously going to be an outrageous value in your environment, but since the environment I am using does not have a lot of data, I wanted to pull enough to show something on the report. In a production environment, you would be using intervals in the 10-minute range to probably no more than a day. And here I'm using the date of October 10th, 2025. Pulling up the address export INCR report and entering the same values I did before, starting with 10/10/2025. And 500,000 minutes, and clicking apply. You can see that all of the data is still here in the date ranges that you selected for the start date and the interval in minutes. Moving back to our curl again, you can see the name of the report is today address export INCR. And the data values we use are the same that we just demonstrated in the UI. Now we're running the curl command and pulling up our window to find the exact location that we had specified with the curl. Here you can see today's address export INCR. And if I open this, you'll see a CSV file with the same data that we ran through the UI.